3, 2, 1, go. 30, 6 right.
In this series we are showing how to get and use the telemetry data from Dirt Rally 2. This video is about getting the data in C# code and displaying it in its raw values like this. I will upload the code to GitHub, so have a look in the description below to see the link. Let's create a new C# Windows Forms project. We will add a button and change its text and name to connect, and then we'll double click it to go to the code for it. Here is a simplified version of the code. On this line we use the system net sockets to make a UDP client, and we set the exclusive address use to false so we don't lock the port number it is listening to. We then make an IP address using the IP address from the config file and set a variable to hold the port number that was defined in the config file as well. We then make an endpoint from those two variables and tell the UDP game data to bind and listen to that endpoint. Next we will call the receive method of the game data, and this is the bit that has a problem at the moment. Currently it will lock the UI thread and wait here until the game sends a message before it continues down below. This is not what we want to happen. We would rather the app stays responsive and just informs us when a new message comes in. The last bit of code just closes and disposes the game data connection when we are done listening for messages. A good way to fix the UI lock is to use asynchronous programming, so let's make this method async, and we'll update the listen to have a method that is async as well. We now await the new listen method. This allows the main UI thread to continue running smoothly while the listen method handles its own work separately. I have added the new async listen method. It has a loop. We do this as we don't just want one message, we want to continue getting data from the game while the listen method is running. The loop code will wait at the receive async call, and once the game sends a bit of data, we will read the buffer to get the bytes for its message. It will then loop around and wait for the next bit of data. There is one more thing we need to do. Currently the listen method is in a never-ending loop, as we are looping while true, so we need a way to exit it when we want to stop listening to the game data. The way to stop the listen method is with cooperative cancellation. We declare a token source at the class level. Before we start the listen loop, we make a new cancellation token source and pass its token to the listen method. In the listen method at the most reactive spot, which is just after it receives a message, we check the cancellation token to see if a cancellation has been requested. If so, we call return to exit out of the listen method. Now, all we need is some code to cancel it. To do this, we'll add a new disconnect button, set its text and its name. In the disconnect button code, we can check if the cancellation token source has been created, and if it has, we can cancel it, and at that point we can dispose it. I will tidy up the code a bit now. I will disable the disconnect button in the form designer, and I will enable it and disable the connect button once we have started the connection, so that way you cannot accidentally connect twice. I have moved the disconnect code into its own method and call it from the disconnect button as well as from the form closing event. Then in the disconnect, I will enable the connect button again and disable the disconnect button. This will ensure it's always disconnected whenever we end the program. It's time to give it a test to see if it's working. Make sure your Dirt Rally 2 config file is set up correctly to send out its game data. I explained how to do that in a previous video if you missed it. Let's put a breakpoint right after the receive async so we can see if we are getting some data. Run the app and press the connect button. I have Dirt Rally running in windowed mode, so I can test this more easily. If we start the game, we should see the data come through. And there it is. If you hover over the buffer, you can see it is a byte array. This is the byte data coming from the game for this message. We will now have a look at turning that into something more readable that we can actually use. I have added a new class with a structure to hold the Dirt Rally 2 telemetry data. It is used to convert the byte array into named properties with the correct array offset and field types. Once it's in this format, the data makes a lot more sense. I have another video that explains each of these properties in lots of detail, the complete missing telemetry guide, so make sure you check it out. You won't find a more thorough guide anywhere on the internet to date. I have also commented out the properties that don't make much sense in this instance. They are always 0 for Dirt Rally 2. This happened because they were inherited from the F1 game structure that Dirt Rally 2 is just reusing. Let's update the code to use the new structure. I added this method. It is a good way to convert the byte array to a structure when the structure has all the correct offsets for the byte array we are converting from. Once we have the structure, we can use it like this. We pass in the data array and it will be converted to our own structure then, which has all the properties from the Dirt Rally 2 game in a clear, readable way. This will give us a nice base framework, so from here we can code whatever we can imagine. Now would be a good time to display the data. I have added a bunch of labels to my form to show all the values, and I have added a method to set them from the telemetry structure into these labels. After we get the data, I'll call the new update method. There is a few things we need to be careful of when calling this method. Firstly, this receives a lot of messages very quickly. The config file controls the rate at which the messages are sent, with the default 1 meaning 1,000 messages a second. It doesn't actually come that quickly though. It is based on things like frame rate, UDP bandwidth constraints, and internal rate limiting added by codemasters to prevent flooding the network or overwhelming telemetry tools. Realistically, we get about 10 to maybe 20 messages a second. You could, for example, set it to 1,000 if you just wanted to get one message per second. To handle the high speed, we'll use a currently updating boolean. We will check that it is false before the update, set it to true, do our update, and then set it back to false when we have finished. So our update code only runs again once it has finished the last update completely. Secondly, when the messages are received, they come from the UDP socket thread. We need to call our code on the UI thread, or we'll get cross-threaded exceptions. Using an invoke action, we can get back to the UI thread to do our updates. Let's see it in action. I'll press the connect button and then start the game.
5, 4, 3, 2, 1.
Awesome! The Dirt Rally 2 telemetry is coming through perfectly. Don't forget to check out our other video, the complete missing telemetry guide, to help make sense of all these numbers. Subscribe to see our future videos where I'll turn these numbers into gauges, maps, scoreboards and other awesome things.